I want to do one more video with you with regard to the use of Newton's method to solve problems in Excel. And in particular on this one, what I wanted to illustrate is that this equation is going to have a little repetitive piece that's going to, I'll just show you a little way to save a little time in Excel when you're doing this. Here's our little function, g of x equals e to the x times the sine of e to the x. It's this nifty little function that both gets to be a chirp function. It gets faster and faster the farther you get out on the axis, but it also gets higher amplitude. It's kind of a nifty little function. And we see that there is some kind of root or zero of this function somewhere near the value of x equals 2.5. Let's see if we can actually solve that function using Excel. Now I'm going to go ahead again and change the view on there to 200% just so that it's a little easier for you to read. Alright, so let's go back down here to our place here. Now, we're going to start with our first guess, and I told you our first guess would be 2.5. Now, when I actually look at this equation here, x sine e to the x times sine of e to the x, there's already two places where I'm going to be typing exp parentheses and move it over to x. I'm going to be doing that 2 times right there. The derivative of this thing, by the way, g prime of x, is this, listen to this, e to the x times the sine of e to the x plus e to the x cosine e to the x times e to the x. There's 1, 2, 3, 4, 5 e to the x's in that equation. So we have a total of 7 of them. Rather than have to type e to the x, or exp of x actually, so many times, it actually makes sense to kind of set up one column here equals exp of this cell right here, and we just have that value now. And whenever I need it, I'll just point to this cell to get that value again. So for example, for our g to the x, g of x, it is equal to e to the x, which is this, times the sine of e to the x, which is this cell right here. See how we just did that? And we got that whole e to the x times the sine of e to the x got entered in just that tiny little bit of code right there, and we avoided any mistakes or anything. Same with g prime of x. I mean, this thing is e to the x times the sine of e to the x plus e to the x cosine e to the x times e to the x. So it is equal to e to the x times the sine of e to the x plus e to the x times the cosine of e to the x times e to the x. Again, a really messy equation, and I got it in just, a relatively handful of little steps right there. All right, this makes x of n plus 1, remember, is equal to xn minus g over g prime, g over g prime. So that's our value of x2. All right, going back over here, we're going to get our second entry is that one plus 1. And this value here is a relative reference to this cell right here, because this is the same, this is x2 in both cases. Okay, and then the rest of this just gets copied over. Okay. This is e, see how that's a relative reference here? In the first cell here, let me undo this here. See how it's exp of f32, but since it's a relative reference, when I copy it down 1, it becomes f33. It just means 1 to the left of where I am. All right, so we've got this, we got this. All right, this looks good so far. If I copy this down a few more rows, see what we get here? Yeah, look how after, by the time we get down here to x is equal to 2.53102, we get values of g of x as being times 10 to the negative 15th. I mean, this is a very, very small number. So we have solved for this root. Where are we at here? This root of the equation, where are we at? It's actually this one, is at 2.53102. All right? And we simplified our equations a little bit by adding one extra column here for a piece of the equation that we simplify a lot. In your homework, I think it's the third problem set, the one that you use, the third problem rather, I think it's the one that used the Kohler curve. You're going to find it useful to have columns for different parts of the equation, just so you don't, the whole equation would be like a whole screen long. I mean, it's a big messy derivative. So you're going to divide it up, and I'm going to be guiding you with that on the homework set. To different terms. I think I called them alpha, beta, gamma, whatever. And okay, the numerator of this equation is alpha plus beta plus gamma. So first compute alpha, which itself is a long equation, then compute beta, which itself is a long equation, and then compute gamma, and then have another cell that's just the alpha column plus the beta column plus the gamma column. And you'll see it's all explained how to work through that on the homework set. All right, I hope that's everything that you need. Please let me know if you have any questions. This has been Dr. John Schrage.